Hello and welcome back to a new video in my Unreal Engine 5 tutorial series. In the last video we have implemented, or in the last videos actually, we have implemented the moving statue and XP collectible actors that can be set to which class they shall respond. For example, this XP actor responded to the movement of the statue, and we also implemented a callback inside of this collectible actor, or basically inside the statue when it hits a collectible actor, that it can play a sound, for example, on the statue. And when it all came together, we basically had multiple of these XP collectible actors, some of them collectible by the user and one of them collectible by the statue, and the statue is going to play a sound every time it hits a collectible actor. So to show this to you again, I can here now move around and I can get close to this one. This is player collectible, and boom, it jumps and disappears. Same here, jumps, disappears. Then we have the statue. If I get close, boom, it has collected it and then exploded basically because it collected it. So this is all fine and all working, and we could potentially already do a game with that. We could maybe build a level and we could hide multiple of these XP collectible actors in the world, and then the player would just need to collect them all. Of course, there would still be a bit of logic required, maybe that the times how long you need to find all of these. But actually, do you want to do this with the current state in which we are? No. Because the camera that we have is actually not very fun to play. We can just fly around the scene wherever we want. So basically the player character, the player actor, I'm just gonna call this actor for now. The player actor is basically just able to move around freely, and we don't want to have this because, well, I think there's no game where you can move like this. Maybe if you have a sandbox game, then you can maybe move around like this, and then you can press a button and place objects around. But yeah, mainly you don't want to use this special camera, the special character type, actor type. And to get to it where we can customize this, we first need to take a look a bit of the architecture of Unreal Engine. So how does spawning the player in the level actually works? If I go to the outline, you can see we have some audio here, we have this player start here, which we're gonna get into in a second. We have some lights here. We have this reflection capture, sky and fog, static meshes, volumes, post-process volume. We have the My Statue, our XP collectible actors, another fun ones of these reflection captures, wherever this is not grouped here correctly, but yeah. So basically we have a lot of stuff in here, but we don't have kind of like a player in here. The only player related thing that we have is this player start. But this player start thing is actually not present in the game. If I would start the game and tap out with Shift 11, you can see the player start is still in here. Can actually zoom to this. I don't think so, because we cannot even see it, but the player start is in here somewhere, but as you can see, it is not visible anymore. It's not actually the player. The only thing this player start basically indicates is a location, a position, basically this arrow position, vector position of that blue vector arrow, and the only thing this basically represents is a position and direction where the player should be starting. And what the Unreal Engine does when you start playing the level is searching the whole scene for this player start. This might also be done during baking when you are exporting the level, but I'm not quite sure of that. So basically what it does, it tries to find one of these player starts, checks if it's the correct one, and if it's the correct one, it spawns a actor at this exact position, which indicates that the player starts at that exact location. So it spawns an actor, a special player actor, and does the required setup so that we are actually attached to that actor. And actually, the player itself is not a default actor, because a default actor cannot receive input. It is just a static object that sits around. It might get replicated to server and clients and synchronized across multiple systems and computers, but it has basically no code attached that handles like getting input from the keyboard, getting input from the mouse. And therefore there is a special implementation of an actor that can basically get input, that has all the code required to be possessed by a player. That's like the term how Unreal Engine likes to call it. They are calling it possessing something. So Unreal Engine, if a player wants to kind of like control a special actor, it needs to possess it, but by default an actor is not possessable. There is a special class, superclass of actor that has been implemented for exact that purpose. It's called a pawn. and the pawn can be possessed by a player. And the interesting thing with this concept is that it is not only like a single concept. So it's not like in one game there is one pawn that can be possessed by the player. No, there can actually be multiple pawns, and they can be possessed by multiple like player types. Let's call this like that. The most straightforward player type is the player that is currently sitting in front of the computer, that is kind of like pressing the buttons, pressing the mouse. So it's very easy. It's basically just routed through the Unreal Engine's internal data structs and data flows to that special actor, to that special pawn that is then basically responding to the keyboard inputs of the current player. But if you have a multiplayer game, there might be also like the remote players that are not locally on your machine. And if this is the case, then of course you need to do this somehow over networking. And this is all basically handled by the implementation of the engine and by the implementation of the pawn. What's also possible is that the pawn is controlled by an AI. So if you have like bots or a player disconnects and you want to replace him by a bot so that the game can continue, then basically the pawn is automatically switched and now is being possessed by an AI controller or by an AI system, and the AI system is now kind of like playing the player. And this is an important concept to understand. So basically, if you want to create something or implement something which is like a character or an enemy or anything that kind of like is playable, then you build this as a pawn, and the pawn is then possible to receive input and is also possible to be possessed by, for example, a player. And this player can be anywhere. So this is all handled under the hood in the Unreal Engine itself. We just need to implement the pawn, implement all the default functionality, all the input functionalities, and so on to basically implement that. And that's what we're going to do today. Today we want to implement our own pawn. And we can actually do this. So if I go up here to Tools, New C++ Class, I could select the pawn, but let's first zoom out so that I can actually select it. There we go. We have this pawn here. So this was the actor that we always used, and this is now a pawn. And as you can read, a pawn is an actor that can be possessed and receive input from a controller. We're going to get to it what a controller is, and we're also going to talk a bit about game modes in this video. As you can see, there's also a character which is a special type of pawn that includes the ability to walk around. So actually you will think that the character is way better to basically create what we want to do now, and it's actually true. If you really want to build a character, you want to do this, but in our case, we're just going to start with the pawn, actually, because I want to do this step by step and not go full in. I think we're going to get to character at a point where we create a real game, but in this tutorial series, we're just going to get to the pawn. And, or at least for now, we're just going to get to a pawn because I think it makes a bit more sense to build this up slowly on top of each other and not directly dive in full around character. So we want to create a pawn here. So let's click next. Let's give it a name. Let's call it the XP pawn, because this pawn shall be able to walk around and collect XP. So its name is going to be the XP pawn. It's going to be created in our default folder. We're not going to do subfolders for now. So let's create the class. Very straightforward. And let's see what we get. Alright, now we are inside of Visual Studio, and we have, it has created ourselves an xp-pawn.h and an xp-pawn.cpp as always. And let's take a look at the class AXP pawn. First of all, it's inheriting from the class pawn. If you would peek into the pawn class, you can actually see that a pawn is an actor. So as I told you, a pawn is an actor, but it also has this AI agent, nav agent interface, and a lot of function like get movement component, get movement base, and so on. So there is a lot of stuff inside of here. And what all this stuff does is adding the functionality to be possessed and controlled. For example, here you can see T subclass of an AI controller class, I think it's actually AI. Yeah, controlled by an AI. Default class to use when the pawn is controlled by an AI. So if you write an AI, you basically implement an A controller class and you write your all AI functionality in here. And then when you kind of like spawn the pawn and say this shall be controlled by an AI, it's going to also basically create an AI controller and use this AI controller to control the pawn. There's a hell of a lot more stuff in here. So I'm not going to take a look at the full header, just a just a short information what's going on here. For example, you can also use player states for a state that the player, the pawn, currently has. So there is a lot of useful stuff in here, which is all player related. We're gonna tackle this step by step. If you take a look at what we have get here, you can actually see it's quite similar to an actor. We have a constructor, we have a begin play event, and we have a tick event. This is all the same. If you would take a look at the CVP file, okay, we can see a constructor. Also, this primary actor tick can ever tick true. Begin play, also an empty begin play event, tick event, empty tick event. All the same like in an actor, because it is basically an actor. The only thing that is now different or new is this one, virtual void setup player input component, which gets us in parameter and new input component pointer, player input component. This is a special component that is attached to a pawn by default, and this special component handles player input. And what we can do basically in this function is we can register what inputs we want to receive, because by default, if you just spawn a pawn, it's not going to do anything. You cannot move it. It has no functionality attached. We have used previously the default pawn, and the default pawn basically has some I think it has not even implementation in here, but I'm not quite sure. Maybe it has. We would need to take a look at this file. All right, so I just have opened up the player, the default pawn, the default pawn class. And as you can see, we also have this function setup player input component. And as you can see down here, there is some setup going on here for move forward, move right, move up, turn rate, look up rate, and a lot of stuff like that. So basically, it has some default implementation attached that handles all the input. And you can also see like this code here basically binds it to some buttons. So if we would take a look at this here, you can see W, A, S, D. This is basically all inside here. This is a special code. We're not going to do this like it's done here, because this is like static. If you do this in C++ and basically say this move forward event is handled by by W, and the move right is handled by A. If you do this in code like that, then it's basically static and you cannot change this. But on the game, you actually want to be able to have some configuration so that the user can actually change the key bindings. And it's not possible if you do this like that, or it would be possible, but you would need to write this all on your own. But Unreal Engine has actually the possibility so that this can be done dynamically, and you can change this via engine configuration files. So we're not going to do this like that. So what we're going to do here later on, but we're going to tackle this step by step, is we basically want to register all events, it's called axes and actions. Axes for stuff that is like analog. For example, if you are on a gamepad, then the movement is most of the time analog. So you have an analog stick for movement. So movement is always analog, and the key press, for example, W, is just pulling it on full speed forward. So this is kind of like an axis. And you also have actions. For example, if you press space to jump, or like E to interact on objects, and on the controller maybe it's the A button to interact. And yeah, this is kind of like an action, just a single button press. But we're going to get to this in a few seconds. The first thing that we want to actually make sure is that this pawn class is actually used. We can already take a look at Unreal Engine here and open this up, and if we go to the C++ classes, then you can see our XP pawn has already been created. Later on, we're gonna go in and create a blueprints implementation of that class, but I want to first make sure that this pawn is actually used inside of our world. And to do this, we need to understand the concept of a game mode. A game mode is basically a class that describes how a level is being played, or a world. We already have taken a look at this when we click on this button up here, list of world blueprints available for the user for editing or creation, whatever. We don't care about this, but we always have visited that one here, this project settings, game mode base. And this game mode base is a game mode that is implemented by default in Unreal Engine, and this basically defines which classes are used by default. So as you can see, for example, there is this game state class. This game state just handles a global state of the game that is not player related, and you can see it is using this game state base class. We could also edit this here, click on the button, and it would open up this in Visual Studio. It's basically just a class that stores the global state of the game. We could change this here, as you can see. Normally you would be able to select the class or create a new one, but since we actually are using like a raw C++ class, we cannot change this one here because this is like implemented in the default Unreal Engine C++ code. So if we would want to change something of that, which we want to do, not for the game state, but later on for the pawn, we would basically need to create our own game mode so that we can use it. As you can see, there are a few more things in the game state. There is, or not game state, the game mode, sorry, is for example the pawn. The default pawn that we have always used and casted to, it's basically set it up here. So you can see the pawn that is being used for a player is the default pawn. You can also see there's also some more stuff like a HUD, head-up display. This is basically for UI. For example, currently it's using just this HUD.h class, which is, I think, just a null HUD or some default implementation that makes also visualizations possible, probably, that are shown sometimes in here. Another thing that can be controlled here is the player controller. The player controller is the middleman between the raw keyboard inputs and the inputs that we subscribe as the pawn. So basically it's just a middleman class that can do some additional stuff, validation, maybe some computations, maybe convert a linear movement to a logarithmic movement if you want, and stuff like that. But probably on very basic projects you're not gonna need this, but by default, it's basically this player controller, which is just some plain forwarding. All right, so basically, currently, as you can see, our default pawn is set up here. And to change this, we need to create our own game mode. And actually, we have already a game mode. By default, if you take a look at Visual Studio, the Unreal Engine created ourselves this new CPP tutorial game mode base.h and new CPP tutorial game mode base.cpp. And basically, what this is a full empty game mode. But as you can see, the Unreal Engine itself, this game mode is not even selected. We can do this actually quite easily. We can click on here and we can now actually have two options to set this game mode. By default, inside of the project settings, there is a default game mode that is used for every new level. So every new level is going to automatically get the game mode that we select here in the project settings. But what we can also do is we can also select a world override, which is then just for the current open world, which is currently the minimal default world. We can do this here as a project settings because we're just going to have one level here. Maybe in the future another level to show you how you can travel between levels and have loading screens. But for now, we're just going to be quite strict and we're just going to say, all right, we're just going to override the project settings. Later on, we can also, of course, change the world override as well. So to basically do this, we would go down here to select game mode base class, and now we could select the new CPP tutorial game mode base. If I click on that, boom, we now take a look at this new CPP tutorial game mode base. It has selected our C++ implementation. If we click on this edit button here, it has opened this up in Visual Studio. It was already open, so you didn't saw a change here. But basically now we have switched to our own empty implementation. And since we have an empty implementation, it is just like the default one. And we have the default game state base as well, the default pawn, default HUD, and default player controller. So the next thing that we would want to do is we want to actually override this. One thing that you actually want to do always, we always did this, we always did never select the raw C++ classes as our objects. We always created a blueprintable version on top of that. I want to do this here as well because it just gives us a few more options. And it also allows us to quickly change this down here because as soon as this is blueprints, we can actually select different states down here. So if you want to debug something, you can just quickly go in here, quickly just switch the pawn, test something out and switch it back. So this is actually quite useful if you are doing this in or with a blueprint on top of your C++ implementation. So what we can do, of course, we could like go to the content browser, go to our classes, select our new CPP tutorial game mode base and say create blueprint class based on blah, 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 blah. Do this all the default way, but no, there's actually a more easier way, which is also automatically selecting our newly created one. So what we can do down here is just hit the create button or the create entry here in the menu by the project settings game mode, create, and then we're gonna select the superclass. In this case, we're gonna use a new CPP tutorial game mode base. Gonna click on top of that. This is well zoomed in, but it's actually sufficient. We don't need to zoom out here because I see everything that I need. Just select the folder where it shall go in. I'm gonna select the content folder, then I'm gonna give it a name. Just gonna call this my game mode. Hit enter, which is not doing anything. Hit save, which should automatically open up the new my game mode that we have just created. There it is. And if we would go back in here and take a look at this, you can actually see the game mode is on a project base, the my game mode. And now if we come down here, you can actually see that we could in theory change our pawn class, and now I could actually go down here and select the XP pawn. But we're not going to do this like that because, well, of course we want to do the C++y and have our own parameters in there and make this a bit more safe and a bit more controllable, and also to show you how you can do stuff, and also can alter some classes before begin play is actually called, because actually the when a begin play event of the game mode is called, there is a begin play event. I have not shown this to you, but if I would go to the a game mode base and I would implement the virtual methods, if you don't have visual assist in here, you might need to take a look at the Unreal Engine documentation, but you can actually see that it's actually not called begin. Is it actually called begin play? Let's see. I think it is. Yeah. It's actually an actor, though there is a begin play event that we can override. There is actually a special event in here. If we scroll up a bit, we're gonna see that there is actually this init game function and the start play event, which is a bit more reasonable because it basically is related to the gamer base. You should probably use that one. But the thing is, if start play is already called, then the pawn has already been spawned. And to actually change the pawn, we need to do this when the game state is initialized. So as soon as the game state is initialized, we are allowed to change classes, because after initialization all the objects are spawned. So if we want to change our default pawn programmatically, we need to do this in this init game state function. So what I'm going to do is quickly override them. If you don't have Visual Studio Assist, you can just type this on your own. It's just a void function named init game state. So quite easy. And inside this init game state function, after we code the super, of course, we can basically set the default pawn. And actually there is a member called default pawn class, and this default pawn class member is basically telling Unreal Engine what default pawn to use. And in this case we're gonna override all settings that we might do here. I'm doing this on purpose. So actually if you change that one, this will no longer be applied, because we're gonna override this on the init game state. Why I might now wanna ask if this is really necessary or if this is good practice. That actually depends on. If you really wanna limit this game mode to what pawn is used, then yeah, this might be reasonable. What we could also do is you could also bring the functionality of that back. You can basically check if this is equal to the default pawn static class. So you could actually check if that is equal to that. Why is that not? Yeah, the a default pawn is probably not in here. A default pawn is in what header? Let me quickly open up the Unreal Engine documentation. It's in the game framework default pawn. So if I wanna reference that, then I should do this like that, and now this should be good. So what I could do is I could change, I could see if we have this default pawn. So basically check if no hard override is active, and when no hard override is active, then I'm just gonna update to custom implementation. And what I could do now here is, if I'm gonna do this like the bad way, then I could, let's maybe do this like that, then I could do this like that, and just gonna include the XP pawn. There it is, XP pawn. And I could just basically say XP pawn static class. It's actually the XP pawn static class, and then I would just have the XP pawn in here. But nah, this is actually not clean, because we cannot change this, and we want to be able to change something like that on blueprints. So let's actually go down here and create a member, a private one. And what we earlier had, we had this like uClass member, uClass pointer, and we called this maybe custom pawn class. This is be equal to, I already delete, I don't have this not in the, I never copied that actually. Static class, and of course I already forget the A static pawn. I could do something like that and say, alright, this is a U property, add it anywhere, and boom, we would be able to select this. And to make sure that this is not, that you never have this as a null pointer, you could set this to no clear here, so that you're never gonna clear this. And this would be totally fine. Now you could select the custom pawn class. But I actually want to make sure that we always set this to an XP pawn. And actually this is quite easy. You can use something that is called t-subclass of. This basically says that this parameter, custom pawn class, needs to be based on the templated class that we put in here. So if I do this like that, then you are only able to select the XP pawn or any class building on top of the XP pawn. So this basically limits this member, this custom, let's maybe call this also custom XP pawn class. This would basically limit, this t-subclass of limits everybody that uses blueprints to actually use an implementation of this XP pawn. So this just makes sure that this is actually XP pawn that is used within that game mode. And instead of doing this like that, I can just assign this to my custom XP pawn class, and then boom, we would have set it up the correct actor. So let's try this out. Let's compile this. Let's see if I didn't make any mistakes. And there we go, it compiled without issues and reloaded it. And if we would take a look at the My Game Mode now, and we're going to select the My Game Mode here, you can see that the new CVP tutorial game mode base has this custom XP pawn class exposed here. Down here are the default ones, I just collapsed them. You can actually see there are more of them than just the ones that we saw. So there is also this player state class that you could select, default pawn class, spectator class. So there are actually multiple, or are actually more classes that you can override than what we got exposed here. But these are like what we exposed here basically. So, but these are like the most basic ones. And now what I could do is I can select the custom XP pawn class, and you can see if I go in the drop down, we're just gonna get our XP pawn currently, because well, the XP pawn is currently the only class that implements an XP pawn, because it's the only one that we created. But if we would now maybe go in and create a blueprinted version on top of that XP pawn, what we're gonna do in a second, then we could also select the blueprinted version, of course, so that we don't use like the default C++ template, which is of course has no mesh assigned to it, no customization assigned to it. So this just makes sure that this is all working. Let's actually try this out. Let's click play. And yeah, it is working. We have spawned inside of our level. The position where we spawned is actually quite interesting. We can do no movement, we don't move our mouse, and it is actually looking quite bad. Why is that? Well, because if I would go into the outliner, and now I'm gonna click on my XP pawn, because this is the player that has just been spawned, and go on the details panel, you can see that this XP pawn has nothing attached to it. And if basically what the Unreal Engine does, it searches for a camera. On the default pawn, or the pawn that you selected, it is going to try to find a camera component. And if it doesn't find a camera component, it's just spawning the camera at 0, 0, 0. So it's just spawning a camera at the origin with default transforms. And this is actually bad because, well, the camera or the player start was at a complete different location. And we want, of course, a custom camera that we can also move around and have some FOV that we can control. But this is now not all in here. Why is that? Well, of course, because we have nothing attached here. And how can we do this? Well, of course, we need to have some components on our pawn. So as you can see, basically when I stopped, I was exactly at this position here, which is actually the BP sky sphere, which sits at the origin with like default parameters. So this is like the origin of the level here, directly at the origin. Alright, so now let's start and attach some components to our pawn. So go back to the xp-pawn.h and let's create a private section here, make them your property, edit, defaults only, and let's add the components. So first I want to have a use static mesh, which is basically our player mesh. Let's call this one player mesh. And then I want to have a edit defaults only u camera component pointer, player camera, to set up basically a mesh and a camera. So, how are we going to do this? Well, of course, we need to include them. The static mesh is already included because we do have it in here already, because like the default pawn is including this already, but I just want to make sure that I include this one as well, the static mesh. Let's also search for the camera component. I think it's something like components camera or something. Yeah, no, it's camera components, but you can just, if you need to define them, I think I showed this earlier in videos, just copy the class name and put this into Google and it will, the first entry is going to be the Unreal Engine documentation. And don't care if this is set to 5 or 4 point whatever, the class names and the headers are probably the same. So just don't bother always switching to UE5, because that it has nothing, most of the time there are not big changes between 4 and 5. Except it is like a 5 only feature, of course, or a deprecated feature from 4 that is no longer available, of course. But most of the time, your Unreal Engine 4 documentation will work quite fine. So this is basically the mesh, display, and the mesh being displayed, and this is the camera to view the scene. So now this of course needs to be set up, and we're gonna start by the player mesh, and let's go in here maybe and set up component hierarchy, which I probably mistyped again, but it's okay. So we're just gonna create a default subobject. It's gonna create a name, which is our player mesh, and of course it's gonna be of type U static mesh. So there we go. Then we just want to say that our root component is going to be equal to the player mesh. Then we want to select the camera. This doesn't work. Why? Okay, it's a U static mesh component. Of course, I made a big mistake here. The static mesh is just the static mesh that's going to be used. We of course are looking for the static mesh component. There we go. Now this works. And now we can also create the player camera, and the player camera is going to be a new camera component with the name player camera. No, not caps, camera. There we go. And then we just want to say player camera, set up attachment, and it's going to be attached to the player mesh so that it moves relative to the player. Like that. And this should properly set up our components, and what we can do now is we can create a blueprint version on top of that, assign a mesh to that player mesh, and also move the camera a bit off and configure FOV and stuff like that. There we go. All right, so let's go in Unreal Engine 5, compile this on the fly, which should give us the newly, freshly created, or not created. Oh, we crashed. Nice. Let's restart. Alright, so one Unreal Engine restart later, we are back in, and of course the XP pawn is in here. What I want to do here is I want to create a blueprint class based on the XP pawn, and yeah, that one does require scaling out again. Bad. Alright, so my XP pawn is actually good. It's going to go into the content, and we're going to create a blueprint class on top of that. There it is. Of course you want to see something. There we go. And now we have it. We have the player mesh and we have the player camera. Let's go to the player mesh and select the static mesh. I want to have a capsule. I want to have this white capsule because I like it. And it's not going to get this material. It's going to get some nice material. Ceramic tiles. Yeah, I think this is nice. I mean, it's not really built for the ceramic tiles because of the UV coordinates it has. But you can also say that it's an artistic element, that it is not perfectly right. It's an artistical element, so that's good. You can of course select any other material or create your own fancy custom model if you like, of course. Alright, so the next thing that I want to do is I want to reposition the camera, because currently it is like, well, not in a correct position. It's a bit bad that or a bit sad that we cannot really see the camera's preview here. But yeah, I'm not quite sure if you can. It's somehow possible to show this, but I don't know how, and I'm not bothering doing this. I'm just gonna move it somewhere here because it's gonna be a third-person camera, something like that. You're just gonna have a static position, and we're not gonna bother implementing like fancy camera stuff for now. So It's just going to point it down somewhere like that. And if I now compile this, go back to my minimal default, open up my content, open up my game mode, because I closed that, that's interesting. And go back to the full blueprint editor, of course, because like this happens when you crash. And if I now go to the right here on my custom XP pawn class, you can see now that the my XP pawn is also available, because it is based on that XP pawn, and we basically said that it needs to be a subclass. And of course, what we can do now is select the my XP pawn, save the game mode, go back in here, hit play, and boom! Yeah, we are the capsule that we have just created, and the camera is correctly attached. It is in the correct position. It throws a shadow and everything is nice. But no, I'm gonna press buttons. I hope you hear it. Yeah, probably you hear it because my mic setup is not ideal currently. Maybe on a weekend it gets better. So I cannot really move here. And yeah, that's how it all works together. So what do we need to do? We need to do a similar thing that we saw in the example for the default pawn. We need to set up some axes and actions. I already told you axes are analog values. For example, movement, you can do this with an analog stick of a controller. This is analog. And actions are like button clicks, like spacebar to jump, or the press of the button E or Q to interact or do stuff. How are we going to set this up? Well, it's actually quite easy to set this up in Unreal Engine. We just take this player input component and we basically call a function called bind on it. There are several functions called bind that you can call. There's a bind action, bind axis key, bind gesture, bind key, bind touch, bind vector axis, and fancy stuff. We just care about two of them, bind action and bind axis. We're just going to start by the bind axis. Then it's going to need a name of that axis. In our case, I just want to call this move up down because I want to move up and down. Then you're going to need to have two more parameters. The first, or technically is the second one. The second parameter of this function call is the instance on which this shall be called. This is the current instance or the sys pointer. And the next one is the callback function that we want to call. It's going to be a function on our AXP pawn, and it's going to be called, same as the axis, move up down. And of course, we want to have a function pointer to this. The move up down function currently is not there, so let me implement this very quickly. So we're just going to have a few private functions, and we're going to have a void AX, we don't need this here, move up down here. And of course, it's going to need a parameter. This is actually a float, and this is going to be the value that we have moved up or down. Because, well, a movement of forward, so moving, it's not up down, actually is FB. It's actually move FB for forward backward. I'm an idiot. It needs to be something like that. So basically, if you move forward, it can be also, or moving backward can also be described as moving forward negatively. So this is like the same axis, like if we would see the x-axis as moving forward, then basically saying forward basically moves the actor forward, and backward is basically move the actor backward. Forward is positive on x-axis, backward is negative on the x-axis, and we can actually do this with just one single axis, just like the analog stick that can also be moved up and down, just one axis for forward and backward. Let's also implement that function here. Come on, get here and implement. So how are we going to implement this? Well, the most straightforward one would be the get actor location function. So we're going to get the actor location. We would say location is going to be equal to get the actor location, and we would go in here in the location, take the x1 and increment this by the value, and then we would say set actor location to the location, something like that. All right, nice, fine. Now let's make the left-right movement. FB LR for left-right. Copy this over. Rename it to LR, and instead of X, use Y. Then go up here, duplicate this, LR, something like that. Which would easily work. Alright, implemented that, test this out. Go back to Unreal, reload, and see what we get. Alright, compilation worked. Does that already work inside of the editor? Well, no, because Unreal Engine is not aware of the names. Just because we have the names in here, forward, backward, it's not going to automatically, magically tell the Unreal Engine how this works. We need to tell the Unreal Engine on our own how forward, backward works and left and right works. So how do we do this? Well, we go to our project settings. If you don't have them, go to, where was it? I think edit. Yeah, edit. project settings. Inside this project settings, you have multiple tabs here. You're gonna look for the engine tab, and under the engine tab for the input tab. Inside of this input tab, you have the option to create action mappings and axis mappings. As I already told you, actions button, axis, analog axis. And what we are basically bound to was an axis, so we also want to create an axis mapping. We're going to give it a name, in this case the move forward, backward, and then we can give it several key bindings. So currently you could also go in here, select keyboard and search for your W key, like that, or you can just click on the left here at this button and then just press W. I can show this to you again. If I would maybe create another one here, so you can have multiple bindings to one axis, and for example here, click on that key assign and press S for the down button. You can see it automatically selected S. I already told you forward is going to be W, which is going to be 1, that's okay. And S shall be backwards, and backwards can be represented as minus forwards. So we're just going to type in -1 here to basically say, hey, pressing S should move in a negative forward direction, which is actually what we want. Of course, we can also define a gamepad here, so we can go to the gamepad and maybe say left thumbstick x-axis is going to be our forward movement, and this axis can be positive or negative, so we just need to have 1. It just scaled by 1. If we would want to move hell a lot faster with the gamepad, then we could just multiply, add some more scale in here. But we're just going to do this like that. Alright, let's also create another one here for move left right. So move left right. So we want to have A as left, and we want to have, no, not that one, A and D. D is going to be -1 because right is negative. It's actually different. It's actually the other way around, but we're going to see this in a sec. And can also add for completion the gamepad here. So left thumbstick Y. Now we had x-axis. No, that's wrong. Forward and backward should be Y. And actually not the right one. I'm an idiot. Left Y. And this shall be X. Yeah, it's I am an idiot. So like that. Now we got it sorted out. Alright, so this should now basically tell the Unreal Engine what keys gonna trigger our axis. And if we now go into the default one, click play. Yeah, it works. Or it somehow works. Left works, right works. Forward and backward is actually flipped. So to solve this, we're actually going to solve it in C++, because we could also solve this in here, but since it is called forward backward, this implies that forward is positive. So having forward then negative here would not really imply what the name tells. So we want to actually change that one in C++, just replace the plus with a minus. And now go back in here, hot reload, and see what it does. So here, yeah, now W works, S works, A works, C works. Pressing both together also works. We can move around in the scene without any issues. But actually something seems off. We are flying. Unreal Engine is not that easy with that. So today we're just going to be limited to our friendly pawn that is doing exactly what we are currently doing, and it's actually not even doing collision correctly, because, well, why is it not doing collision? Because maybe we don't have even a collider attached, I'm not quite sure of that, but even if we would have one attached, if we manually add the locations, we're going to basically bypass the physics system, or we might want to bypass the physics system, because this actor here, it is static, we cannot move it, the physics system is not going to move the statue, and we are also static and we're moving around, so we can move in here. If we're gonna make the actor go a bit lower, I can show to you this on the physics object versus a non-physics object. But before we can do this, we first need to get this one back to the ground. Why is it not on the ground? Well, because the actor is spawned at this arrow, and the arrow is not on the ground. So if we are going in here and put this a bit more down, something like that. I mean, it's staying bad size, but if I put this down and hit play, now we are grounded, or nearly grounded. It's not like that. Yeah, quite close. And I can see I basically can move through the statue because our pawn is not doing collision and physics update, and the statue itself is also not doing physics update. So they collide and they would trigger the physics system, but because we are bypassing them and both of them, we're basically getting this issue. If I go into this table, you can basically see that the physics system tries to avoid us, but if it can't, it will not. But yeah, as you can see, This is all working. Also, like these objects, we can push them off because they should work, or sometimes they work, sometimes they don't work. It's always depending on what the physics system is doing, because we are not really interacting with it. This one is working quite well. They are working quite well because, well, they worked. Sometimes they work, sometimes they don't work. It's a bit bad. The thing is, we are doing like movement like we shouldn't not do it, and if we do this like that, then the physics system is not happy with what we are doing. So yeah. But one issue that you saw is that our objects are no longer reacting to our actor. We want to actually fix this one because, well, we want to make them jump. And this is, of course, quite easy because we implemented this in C++. So let's click all of them that shall react on us. Go to the details panel and change the trigger class away from the default pawn to the XP pawn. Or actually the myXP pawn. Let's select the myXP pawn here, let's save them, and let's start, and boom, now they are reacting again. And they should disappear. This one of course not, but these two. So you can see, as soon as the physics system is not able to move the table, we are basically clipping into it. This is just how it works, sadly. Alright, the only thing that is not working is the statue. As you can see, if I go to the statue, it's not really doing its job. And this is because the statue had its own implementation. So if I open up the statue, where is it? Content, my statue. You can see that we cast it to the default pawn here in Blueprint, so this is not good. We need to get rid of this, and we need to cast to my XP pawn. If we do this like that, then we are actually good here. Let's take this one here. Oh, not like that. That one, save, hit play, and now the statue should work as well. Yeah. So this is all working as expected now, except of like these collisions and stuff, but the statue is like going off, so we are not gonna get issues with the statue. The only issue that we get is that it can move through us like that. But this basically is because we are moving this on a forced way. We are forcing positions, and the coefficient physics system is not really happy with that. Also here, sometimes it works, sometimes it doesn't. So this is like not the proper way, but it's okay for us currently to just play a bit around with UE5. Alright, one big thing that is missing is rotating the camera around our actor. Or basically rotating our actor by moving the camera. So let's add that one. And also what's also missing, I find that the movement is quite slow. So what we're gonna add is a few more properties. Your property added anywhere, which is our keyboard, or our not keyboard. Keyboard is wrong, but movement, move speed, float of course. Float move speed, which is going to be equal to 1.0, and now Visual Assist is screwing up the Visual Studio keyboard shortcuts. It's always nice. And here we also want to have our rotation speed, so movement speed, rotation speed, and what we basically want to do is we want to consider them when calculating our offset here, so just the movement speed here. Then we want to bind another axis, so let's call them rotate, and rotate like that. And we can copy this over here. Let's call that one rotate. Let's duplicate this one here as well, rotate. Like that, and now this should be good. And now instead of doing the rotation, we're just gonna take the rotation, get actor rotation like that, and of course then also set actor not location, rotation, and we're gonna put in the rotation here. And what we're gonna rotate around is, which axis do we want to rotate? Let's quickly see that. X, Y, Z, or actually we're gonna always, if you rotate around an axis, we keep the other one the same. So this should be Z, but oh yeah, it's roll, pitch, yaw. I forgot about this. Roll, pitch, yaw. I have no idea in which order they are, but we care about yaw. We care about yaw. Quickly search on Google, always gonna help you. So we're just gonna multiply the value with our speed, rotation speed. Well, how is it possible? Why didn't it suggest us that? sad. But there we get it. So put in the rotation speed here as well, set this up, rotate, okay. Go back in here, do a quick little hot reload. Let's see if it crashes, because it likes to do that. It seems quite stable. Oh no, there it goes. Haha, I thought of that it actually crashed because we changed data structures. We changed the layout basically and how the class is layouted in C++. That is gonna trigger some crashes often, or very often. If you maybe added this on the bottom, it might have not crashed, but yeah. So let's restart this again via Visual Studio, important, so that we don't get any issues with not having the latest C++ version versus Blueprints version. So let's restart this one. And I hate that it doesn't save that, man. That's bad. So yeah, now we should be able to actually rotate in theory if we set this up in the project settings input. So let's add another action here, axis rotation like that, and then we want to have a, no, actually cannot do this like that. I want to have this like mouse, and I want to have the mouse X here. Let's also maybe add the gamepad right something x-axis here as well. So let's save them here. Now we should have the rotation in here, and we should be able to move the mouse and rotate. No. Why? Why is it? Why are you not able to rotate? Did I rename them wrongly? Where is my issue? Rotate. Oh, it was rotate, not rotation. Okay, yeah. That's the issue. Now you can see we can rotate around and we can move. I personally think the rotation is too fast and the movement is too slow. So let's fix that by opening up the MyXP pawn. Let's go in a full blueprint editor. Let's maybe make the movement speed to 3 and the rotation to 0. 0.66, something like that, I think should be sufficient. And going in here should then, yeah, now we are moving. Oh, I think the movement rotation, I think, is actually fine. Rotation, I think, is fine, but movement is still a bit too fast. And one thing that you might have already noticed if you're following this like one-to-one along is that if we now rotate and press and keep pressing W, we are always moving in the location which was initially W. So actually, as you can see, currently we are not really depending on the axis that we had there. So this is bad. We do not really take account the rotation in the movement. And if we take a look at the code, it's actually quite obvious because we're just moving the y or x value. But we can actually solve this. Instead of just plainly adding x or changing x, we basically want to add in or subtract in a full vector. And we can do this by get the actor forward vector. So in this case, we want to get the vector that moves, that the actor is pointing in forward, and just going to try add in here again. And this forward vector, we're just going to multiply this by the value. So forward vector multiplied by value added on top of the location should move the actor in the current forward location. Current forward location. And on the y-axis should also work similar. Get actor, you would now think left vector, but there is no left vector, it's actually just the right vector. But since we have left right, we're just gonna take the minus of that and multiply this in. And instead of the y, we're gonna apply this to the full location. And this should now make the movement correct. So let's compile the changes in. Just change some code so this shall never crash. And if we try this out now, moving forward works, moving backward works, left works, right works. I'm turning, forward still works. I'm a bit slow. Did it reverted these? No, it did not, but did I multiply them in? Oh yeah, I'm an idiot. Of course I need to implement my speeds. If I don't have the movement and rotation speed in here, then of course it's not gonna be affected. I'm an idiot. So let's get them back to where they were and compile the changes in, because if I don't have them in here, of course they can't work, right? So this shall now begin play. Yeah, now it's considering our movements again, and if we are rotating the mouse, we are always moving forward if I hold W. So this is all working as expected. This is jumping. And this is looking quite good. Actually, left and right does not work with the speed. I forgot to add it there. I'm an idiot to put in the right values. This is bad. Of course, not the rotation here. You probably saw that issue. Recording way too long. Well, because I tried a different approach, and then I just thought, nah, I'm not gonna do this. It's just gonna confuse you. But now these should, yeah, now these are working. These are now exactly as they should be. And we are fighting with the physics system and the table. So that's nice. Now we are talking. Now the only thing that is a bit bad here is that our level is quite static. As soon as we got all our collectibles collected, we are basically done. I mean, we could maybe make the level bigger and spawn a few more in the editor, but that's not what I want to do. I actually want to have them spawned automatically. So I want to have kind of like a controllable spawn rate, and they shall just all be spawned automatically. So just made this a bit bigger here for next video, so that we have a bit more space to move. Let me maybe also go to these two chairs and quickly enable them for physics as well. Physic, where are you, physic? Because I probably have not the static mesh selected. Yeah, they're just gonna get some physics here, so that we can knock them over as well. And I am blind. I cannot find it. There it is. All right, so I shouldn't make them knock over as well. So yeah, go away, chair. I don't like you. Go, my friend. Go away. And now the game is done. We played it and it's done. The only thing that we now need to do is we now need to spawn more of our actors, and we cannot fall down, of course. Maybe we should also add something some bounce of the level so that we can't go out, but I think for now that's actually okay. So next level, next video, we're just gonna spawn some random actors here on random positions, on random time intervals. So that's nice. Okay, so thank you for watching. We're gonna see us in the next video. Make sure to like and subscribe, and have a nice day. Bye.